In this video, I'm going to show you how to complete Lab 4. And the requirements for Lab 4 are that you create a program that takes some input, validates the input, and has at least 2 loops in it. At least one loop has to be outside of your input validation. So what I'm going to create is a program that calculates something called the Fibonacci sequence. And I'm going to put up a video on the Fibonacci sequence that's really cool, and it's useful for a lot of different engineering problems as well as computer graphics and computer modeling programs. So I'm going to start by creating a new project, and I'll call it Lab 4. And we'll right-click and create a new Python file, and we'll call that lab4.py. So the first thing I'm going to do is to have a main module, and I'll call it calculate Fibonacci sequence. So this is going to be a module, and it won't return any values. Calculate. And it doesn't take any parameters because it's the main module. And then the first thing I want to do, so what I'm going to use for my input is I'm going to calculate the first n Fibonacci numbers. So for example, I'm going to ask the user how many Fibonacci numbers they want to calculate. And if they say 10, then I'll calculate the first 10. If they say 20, I'll calculate the first 20, and so on. So this will give me an opportunity to get an input and to do some input validation. So the first thing I'm going to do is get the number that they want to calculate. So, and I'm just going to call that n. And this isn't going to take any values, but it will return a value. So I'm going to set n to that. And then I'm going to have a function or module that doesn't return any values that calculates Fibonacci. And that's going to take n as a parameter. And that's it for my module. So to get the number of Fibonacci numbers, this is going to be a function that returns an integer, a whole number. And I'm going to use a loop to do my input validation. So first I'm going to get the first number, the first input, and then if it's valid, I'm going to go ahead and process it. Otherwise, I'm going to ask the user to re-enter the number. So let's get input, which is a string. So display prompt. And then we'll input the input string. So here's the tricky part. We want to create a function that returns true if the input is valid and false otherwise. So I'm going to say set is valid equal to is valid integer input string. So this is going to check whether the piece of text that the user typed in is actually a valid integer. It's going to return true if it's valid and false otherwise. And then while And then I'm going to ask them to re-input input string, and then recalculate is valid. So what this is going to do is if the user enters a valid input, it's going to skip the whole loop. If they enter something that's invalid, it'll ask them to enter a new one, and then it'll check to see whether the new one they entered is valid. And then after they've done that, so at this point they've entered a valid number, let's get the valid number. Equals int. And we know this is going to work because it's a valid integer. And then return input integer. And so that's the end of our function. And let's go ahead and code just this much to see whether this is right. I still need to create my isValid integer, so let me go ahead and do that as well. So this is going to be a function that returns a Boolean, true-false value, is valid integer, and it's going to take a string as input, and then for the pseudocode, I'm just going to say figure out whether the input string is an integer and return that value. Instead of writing detailed pseudocode that actually matches my program. And the reason is because this is the kind of thing that's typically done differently in different languages. So having pseudocode here isn't going to be particularly helpful to anybody else who picks up this program. So for now, I'm just going to say isValid is equal to is input string of valid integer, question mark. So that's just English text. And then I'm going to return is valid and end my function. Okay. So now let's go ahead and write the Python for this. Def is valid integer, and this is going to take input string as a parameter. So here's the secret to doing this check in Python. You want to use something called try and except. And basically what's going to happen is it's going to have a chunk of code inside of a try clause, and if the chunk of code works, then no problem, proceeds on. But if you get an error inside of the try clause, you're going to get an error that gets caught by the except clause. And I found an example of what the code looks like here. So for example, to find out whether an integer is, or a piece of text is a valid integer, this is what it should look like. So I'm just going to copy this whole thing. I might need to fix the indentation. Like so. Except instead of printing that's not an int if I get an error, what I want to do is just say here is valid equals true, and here I want to say is valid equals false. So this only gets executed if there's an error. Otherwise, this is going to get executed. And then I can just return is valid. Oh, lowercase r. Alright, so this will return true if the user typed in a number and false otherwise. Now I can write this function. And I'm going to set input string equal to input and then we'll set is valid equal to is valid integer of input string. So now I'm going to write the while loop. While not is valid. Actually, it doesn't like that. I think it likes that. And then set is valid to okay, so that will continue looping until the user enters a valid integer. And then I'm going to set input integer equal int of input string and return input integer. Alright, so now we almost have enough to test. Let me go ahead and add the local variables that I haven't been adding yet. So I'll put my declares in. So this one's using a Boolean and this one here is using a string called input string and also a Boolean called is valid. And I think that's everything for that one. And then for now, I'm just going to have my loop here. So def so that's all I'm going to have for now. And then we'll call calculate Fibonacci sequence to run the program. So let's go ahead and run it and see if our input stuff works. Actually, before I do this, I will add a display statement here. So print there. So now I can see if it worked. So how many Fibonacci numbers do I want? So none of these have been whole numbers. So let's go 2. All right, so I got an error here because I can't convert n to a string. So I have to manually do that. So now let's try it. Okay, so that works. Okay, so now I can continue on with my program. So I've gotten a number that's valid, and then I want to calculate the Fibonacci sequence. So let me go ahead and write the pseudocode for that. And the way that the Fibonacci works is basically I have a first number and a second number, and then a next number which is equal to the first number plus the second number. Then after I have the next number, the first number becomes the second number, and the second number becomes the next number. Basically, here's how it works. 1, comma, 1, and then the next number is 2, next number is 3, next number is 5, which is 3 plus 2, next number is 8, which is 5 plus 3, next number is 13, 21, 34, and so on. So the first number is this, second number is that, next number is this plus that, and that's the next number. And then first number is this, second number is that, next number is that plus that, and so on and so forth. So this is what I want to do in my loop, and I want to do it until I've generated this many numbers here. So I'm going to need to have a counter which starts at 0, and then a while loop, counter less than n. I want to set next equal to first plus second, and then I want to output call and I'm going to give it first, second, and next, and then I want to set up for the next round through the loop. So I set first equal second, second equal next, and counter to counter plus 1. So for this to work, I have to initialize first and second. And I also have to use set here for my pseudocode. Okay, so that's about the right syntax. And this will loop through, and then I'm done. So, and module. And then I need an output module. And this is going to take an integer first, integer second, integer next, and I'm going to display. Actually, let me add counter here as well. So counter comma. So that way I can display let's go first plus second equals next. That's a reasonable output line. I'll just leave it like this for now. And now we have enough to implement the next part. So if output and print And that should be it for this module. It's not very complicated. We might add stuff to it later though. And then this one is the hard one. So def and then I'm going to go ahead and add the declare statements here now. And let's go ahead and put the initializations in here so I don't have to repeat them here. So I don't need this one either. And I'm going to get rid of that line because it's not really pseudocode. And I don't have to initialize next because I'm not using it before I set it. And I think that's all of that. So let's go ahead and implement this. And actually, I'm going to make a little change to the code. So I want the first one to come out as 1 instead of as 0. So I'm going to move this line above here. And I'll do the same thing here. It won't change the number of times I execute the loop because the test is still happening in the same place in relationship to the counter. But now my output will say Fibonacci number 1 instead of Fibonacci number 0. And then first equals second, and second equals next to set us up for the next time in the loop. And that's it. So that should be all of our code for that. So let's go ahead and add a call here. And pass in n. And let's see what we have so far. So I probably have some fence post problems. It's probably like if I say 10, I'll get back 9 numbers or 11 numbers or 12 numbers, something like that, because the first 2 are pre-calculated. So I'm going to have to do a little tuning here to make it work correctly. But I have enough to start testing. So I want the first 5 Fibonacci numbers. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus... So these are actually correct. But I'm missing the first one. So it should actually be 1, 1, 2. So 1, 1, 2. So I'm just going to basically have another output line here for the first 2. Is 2. And then instead of outputting counter, I'm going to add 2 to counter. So 1, 2, and then this will be 3, 4, 5. And then I have to change this code here. So 2 plus, and then I'm going to have 2 displays before the loop. Copy that. Two is 1. Okay, so now my pseudocode and code match again. And now, since I'm starting at 3 instead of at 1, and this is producing 5, and I wanted 5, I want to produce 2 fewer for those two. So like so. So this is basically going to go 1, 2, and then 3, 4, 5, instead of 1, 2, and then 5 more after that. So let's go ahead and run it. Right, so the first 5 Fibonacci numbers. 1, 1, 2, 3, 5. And let's run it again. Let's do 8 Fibonacci numbers. 1, 1, 2, 3, 5, 8, 13, 21. So this is mostly working. I have a little problem if the user types, for example, -2, because -2 is valid input. It's a whole number. So I still get the first 2 even if the number is less than 0. So here's what I'm going to do for that. I'm going to say if n is less than 1, return. And then, so before I output the first number, I'm just going to exit back out. And then if n is less than 2, here, return. So that way I don't output the second number. And then the loop takes over from there and should work fine. So let me add the pseudocode for that too. If n is less than 1, then return. And then I'm going to display the first number. And then if n is less than 2, return. Otherwise, display the second number. So 1 works. 2 works. 3 works. And if I enter 0 or a number less than 0, then I don't get any. I think that's correct. So my input list is n, and my output list is counter, first, second, and next. But I'm going to go ahead and I'm going to extend this. I'm also going to add golden. And I'm going to calculate another value here, which is going to be a real. Sorry, I have to change the pseudocode. So I'm going to add declare real golden. And then the golden ratio is going to be next over second. And I'm going to display that. And so I have to add real golden here. And we'll just add that as a second line of output. Like so. So let's start by adding golden as an argument. Misspelled ratio, so let me fix that. There we go. Okay, so that's my output function. And then for this one, I just have to add golden is equal to next over second, and then add golden as an argument. Great, so now let's try it. So I'm going to do 100 Fibonacci's. So Fibonacci number 100 is, okay, this did not work correctly. Oh no, that did work correctly. I'm sorry. It's just that the numbers are really big when you get that late in the sequence. But you see that my golden ratio is 1.618033 and so on. Let's find out what the real golden ratio is. One 1.61803398875. So let's see, 33988. Yeah, it's pretty close. Actually, right to at least 6 decimal points, all the way back to here. It actually approximates the golden ratio really quickly. So even by the 11th Fibonacci number, I'm already within the first 3 decimal points of it. 6. Okay. 1.6180339. So by 30, it's pretty close. So now I'm not only calculating the Fibonacci numbers, but I'm calculating the golden ratio. My program takes one input. It does input validation. It has a couple of loops. It has that loop and that loop, so 2 loops, and produces output. So that's all I need for the lab.